As a storm spotter, you need to know how to read the sky, especially when you see a thunderstorm. There are three basic types of thunderstorms. The first type is the single cell, and this is the most common thunderstorm type here in central Montana. A single cell thunderstorm has a short lifespan that often lasts 30 to 60 minutes. The typical single cell thunderstorm produces heavy rainfall and small hail over a localized area. However, single cell thunderstorms can briefly become severe or pulse. During this brief severe period, microbursts as well as hailstones up to 1 inch in diameter are possible. When a single cell thunderstorm occurs, it's not unusual for separate thunderstorm cells to form nearby or even eventually develop along the outflow or precipitation-cooled dense air generated by earlier cells. The second type of thunderstorm is the multi-cell, and this consists of multiple single-cell thunderstorms clustered together. The typical multi-cell thunderstorm lasts at least 60 to 90 minutes and can produce longer duration heavy rainfall in addition to a range of hailstone sizes and even damaging or destructive wind gusts. In this photograph, cells number 2 and 3 developed along the outflow or precipitation-cooled dense air spreading outward from cell number 1. Flash flooding is also possible with a multi-cell thunderstorm, especially when the cells are slow-moving and follow the same path, and that's what we meteorologists call training. The third and most prolific type of thunderstorm is the supercell, and this has a strong, deep, and persistent rotating updraft called the mesocyclone. An updraft is a column of rising air within a thunderstorm in which precipitation forms. The typical supercell is long-lived and lasts at least 1 to 3 hours. The high updraft strength of a supercell often allows it to produce multiple types of severe weather. Now, it's important to keep in mind that typically 1 in every 5 supercells spawns a tornado. However, supercell thunderstorms often become severe and produce hailstones at least 1 inch in diameter and or damaging wind gusts of at least 58 miles per hour. In addition, supercell thunderstorms can produce flash flooding, especially when they follow the same path as other nearby thunderstorms. Here is a diagram of the typical supercell. Notice the strong, rotating updraft is associated with the tornado if one develops. This supercell is moving from left to right, and notice that it has not 1 but 2 downdrafts. The forward flank downdraft is located in the forward portion of the thunderstorm with respect to storm motion, and that's where the majority of precipitation, including hail, falls within a supercell. In the rear of a supercell is where you find the rear flank downdraft, and it's not unusual for little if any precipitation to fall through the rear flank downdraft. As a result, a rear flank downdraft is often accompanied by a clear slot, which is a pocket of relatively clear and brighter sky. Striations, or grooves, along the sides of a supercell's updraft tower allow you to see the mesocyclone, in other words, the strong rotating updraft. Notice in the lower right-hand portion of the photo, the majority of precipitation was falling in the supercell's forward flank downdraft, while the rear flank downdraft and accompanying clear slot are evident in the lower left corner of the photo. Here's a time lapse of a supercell thunderstorm, and notice how the entire cumulonimbus cloud, or thundercloud, is rotating as the thunderstorm moves along. There are several important cloud features that may accompany a thunderstorm. The first is called a shelf cloud, and this is a low-altitude, wedge-shaped cloud that develops along the leading edge of outflow or precipitation-cooled dense air spreading outward from the thunderstorm. A typical shelf cloud slopes downward and away from the rain core, as shown in the photograph to the right. A shelf cloud is often a precursor to heavy rain, in addition to potentially hail. Also, when a shelf cloud is approaching your location, that means strong, if not severe, wind gusts are also approaching. Here is a time lapse of a shelf cloud, and notice how an expansive rain core is present in its immediate wake. Another important cloud feature is the wall cloud, and this is a lowering of the cloud base within the mesocyclone, or strong rotating updraft associated with a supercell. Typically, a wall cloud is found in the southwestern portion of a supercell, and the typical wall cloud will form after rain reaches the ground within a supercell thunderstorm. In addition, a wall cloud tends to point downward and toward the rain core associated with the supercell. In this photograph, the wall cloud is doing just that, and notice how it points downward toward the rain core within the supercell's forward flank downdraft. In addition, the clear slot associated with the supercell's rear flank downdraft is evident toward the left side of the photo. This is a time lapse of a wall cloud, and notice how both rising and rotating air is evident within the cloud formation. Since a wall cloud is associated with a supercell's strong rotating updraft, and that updraft is the heart of a tornado suction if one develops, a wall cloud is the prime formation area for both funnel clouds and tornadoes. This photograph shows a downdraft full of precipitation, and notice that foot-like appendage is what we meteorologists call a rainfoot. This rainfoot is the result of outflow or precipitation-cooled dense air spreading outward from the thunderstorm, being full of precipitation. And as the diagram to the right shows, it's not unusual for a rainfoot to be accompanied by strong or even severe wind gusts. The last important cloud formation to keep in mind is what we call scud clouds. A scud cloud is fragmented cloud that typically develops along the leading edge of outflow or precipitation-cooled dense air spreading outward from a thunderstorm. As the outflow meets warmer, less dense air, that warmer, less dense or lighter air is forced to rise, and as a result it expands, cools, and condenses into clouds, which may become scud clouds. This photograph in the lower right corner is of what we call a scud bomb. And sometimes these scud bombs are mistaken for a funnel cloud or a tornado. Please keep in mind that scud bombs are not attached to the base of a thunderstorm cell, and they lack organized as well as persistent rotation. In addition, these scud bombs will always exhibit a raggedy appearance, while a funnel cloud or tornado often has a smooth appearance. I'd like to switch gears now and talk about great resources for the latest weather information. When it comes to severe weather information, A great source is the Storm Prediction Center. Its website is www.spc.noaa.gov. The Storm Prediction Center is located in Norman, Oklahoma, and they issue thunderstorm and severe thunderstorm outlooks in addition to severe thunderstorm and tornado watches. Another great source of severe weather information is the National Weather Service's general website, www.weather.gov. When you go to this website, you will see this home page, which will display a map of the lower 48 United States, as well as all active weather alerts. All you have to do is click on the region of your choice, and then you can access the latest weather information. There are other great ways to receive weather info. And I'd like to start off with NOAA Weather Radio, which is one of the best sources of weather information in my opinion. NOAA Weather Radio can literally save your life because you're actually able to program NOAA Weather Radio to broadcast any warning of your choosing whenever that warning is issued for your area. For example, if you want NOAA Weather Radio to broadcast a tornado warning whenever one is issued for your area, it'll do just that, even when a tornado warning is issued during overnight hours. Of course, commercial radio and television are other great sources for weather information, and there are many great websites in addition to those that I just recently discussed. And those websites include the website for our forecast office here in Great Falls, as well as the National Weather Service's mobile phone website, which is mobile.weather.gov. As mentioned before, the National Weather Service is active on social media, including Facebook and Twitter. And I'd also like to talk about some other great apps for your smartphone, including the Wireless Emergency Alert System and an emergency app from the American Red Cross. This Wireless Emergency Alerts, or WEA system, has been a collaborative effort between the FCC, FEMA, National Weather Service, and wireless carriers. And it's designed to provide you, the smartphone user, with a reliable wireless emergency alert system. Unfortunately, not all smartphones are WEA capable at this time. If you want to find out if your smartphone is WEA capable, you can follow that web address shown here, or you can contact your wireless carrier. As mentioned before, the American Red Cross has an emergency app. This will provide you with expert information for dealing with disasters. It also has easy to follow before, during, and after event checklists. In addition, this emergency app will alert you for 35 different disasters, including hurricanes, tornadoes, flash flooding, and even earthquakes. Another great app that I'd like to take a moment to talk about is called MPING, or Meteorological Phenomena Identification Near the Ground. This app allows you to be a citizen scientist and submit your precipitation observations through your smartphone. It's used by the National Severe Storms Laboratory, or NSSL radar team, to adjust the rain and hail algorithms on National Weather Service Doppler radars. Simply put, these algorithms allow Doppler radar to estimate rainfall as well as maximum hailstone size. Lastly, your observations that are submitted through MPING are used to improve computer forecast models and therefore the accuracy of National Weather Service forecasts, as well as for the prediction of icing on roadways as well as on aircraft. Lastly, I'd like to talk about the weather widget that the National Weather Service has designed and is still in experimental stage. Even so, this weather widget is user-friendly and flexible. It's available on most smartphones, and it allows you to easily access and review the latest weather information for your area, including latest weather observations, the latest forecast, and current radar imagery for your area. Thank you very much for taking the time to look through our presentation today. As mentioned before, there are multiple ways in which you can contact us here at NWS Great Falls. Our spotter hotline is 1-800-932-6694, and you can email us at tfx.spotters@noaa.gov. If you're interested in becoming a storm spotter, please contact us at that email address.